Yeah, so this topic, we're basically going to look at the exponential function, the log function, and let's see how we do our calculus with it. We did look at differentiating exponentials last year in a very informal way, so let's do it in a bit more detail. So here we go. If you have an exponential to some function, this is where we've got to be careful. It's not bring down the power like a polynomial, because the function is actually the power that we want to differentiate. So we differentiate the power, that goes out the front, then e, and the power does not change. Now that's if it's base e. If it's any other base, it's very similar. It's just that we also multiply by the natural log of a. Here we go, world's easiest question. Why is e to the power of x? We want to differentiate it. What is the answer? Well, it's e to the x. Because differentiate x, you get 1 times e to the x. That's interesting because it explains why the exponential curve gets so steep so quick. Because we're saying that the slope of the curve will always be equal to the y value. So as we keep going, bang, it just keeps shooting up and shooting up. E to the 5x then, differentiate 5x, we get 5, so 5e to the 5x. Doesn't have to be just one thing in the power. Here we've got f4x plus 3, still the same idea. Differentiate the power, 4e to the 4x plus 3. In fact, we could have a quadratic. X squared plus 3x plus 2, differentiate that. 2x plus 3 times e to the x squared plus 3x plus 2. Going to have to use the product rule here. 3x squared times e to the 4x. So, write down the first, 3x squared. Diff the second, oh, it's an exponential. Differentiate the power, so we get 4e to the 4x. Plus, write down the second, e to the 4x. Diff the first, we get 6x. Let's tidy that up. You're always going to have the e to the 4x as a common factor in these sort of questions. So, we can pull that out eventually, but we also have a common factor there of 6x. Why would we want to factorise it? Because quite possibly the next thing we would do is find stationary points or something like that. So if you've got a solver equaling 0, well, it needs to be factorised. Oh, the one we love. Chain rule, anarchy. Bring down the power, 7, lower the power, 6, diff the inside. Inside is an exponential function. So we get 3e to the 3x. Let's make that look a bit neater. There it is, 21e to the 3x. e to the 3x plus 2, all to the power of 6. Well, have to do a quotient rule. Square the bottom, write down the bottom, diff the top. Oh, diff the top, that's nice and easy. E to the x goes to e to the x. Minus, write down the top, diff the bottom. Oh, the bottom, it's also e to the x. Be very, very careful. Make sure you use your index laws. It is so easy to go e to the x times e to the x is e to the x squared. But of course it's not. Add the powers. So we get e to the 2x there. And a little bit of tidying up. We have 3e to the x over e to the x plus 3 squared. Let's do an actual question and let's find the equation of a tangent. At the point 1, and I'm using the exact value for the y value, it would be e squared plus 1 at that point. We need our derivative, 2e to the 2x. Sub in the x value to work out the actual slope of the tangent, 2e squared. Point slope formula, and we get a lovely looking expression. There it is, 2e squared x minus y minus e squared plus 1 equals 0. I've put it in, of course, general form. Well, here's one where the base is not e. That's fine, we said. We'll do it exactly the same, but multiply also by the log of 4. Now, you'll notice I put the log of 4 in parentheses there, because if I don't, it sort of makes it really awkward. See, if I didn't put the parentheses in, does it become 2x log and it looks like 44x squared? But if I put the log 4 first and didn't use parentheses, then is it log 42? So you kind of need to put parentheses around that to make it clear what you're multiplying by. I thought we were differentiating exponentials, but we can do this, y equals log x, because I'll make x the subject. And logs are the inverse of exponentials, so x equals e to the y. Differentiate that, but I'll do it with respect to y. The x to y is e to the power of y. Therefore, the y dx is 1 over e to the power of y. Well, that would be it if we would just substitute it in y values. If I want to get the x values back in, not a problem, because we know x is e to the power of y. And so there it is, 1 on x. That would be an incredibly long way of differentiating log x. We'll see the quick way in a few lessons when we look at logs. Okay, Voila!